My name is Alya Yacoubi. I work as I'm the head, let's say, of the department research and development of a French company called Zaion. Zaion is specialized in industrialized conversational AI, conversational agents for insurance, banking, and healthcare, and many other fields. And in the R&D, research and development department, we work a lot on emotions, on conversational AI and NLP, and how can we use emotions in those area to make conversation more, let's say, natural with the customers. The subject of my talk today will be about a special item of emotions and NLP, which is context. We will talk a lot about context. I will tell you why in a few moments. For the agenda today, we will start by talking about emotion detection, defining this area of research. What are the challenges in emotion detection in text, and especially in conversations, because it's a little bit different, and what are the main application for this. And then we will talk about some data sets, available data sets that we can use if you want to try a little bit. To work with emotions, with detecting emotions in text, and especially in conversations. Also, if you have and I wish you do, you have your own data and enough data, you can label it, and I will share with you some tips how to label this data, some best practices. And then we will focus on some models that I found in some research work that I found it very interesting, and I wanted to share it with you. Also, our approach in Zaion, and then some words about evaluation metrics, and what we believe in Zaion that it's best practice to evaluate this kind of technology, let's say. So for questions, I prefer to answer all questions after the talk, but you can ask them during the talk. But I will try, let's say, to answer your questions at the end of this talk. So why we are interested in emotions? When we talk about conversational AI and conversational agents, we talk about the main task that is related to those technology. And the main task is usually to understand the user request, thanks to many technologies and many systems of the NLP, for example, the natural language processing and natural language understanding. Some agents, conversational agents, use also vocal technologies to understand, to make the transcription. Often conversational agents are available on websites or messaging apps or so on. So they are available everywhere and in every moment of the day. Usually they have a strong knowledge base about one field, so they have a field of expertise, and also they can do some actions. It means that they have some automation, and those basic features, let's say, they enable the conversational agent to fulfill this three first part, let's say, of the pyramid of needs: accessibility, usefulness, and usability. So with those features, we avoid user disappointment because our conversational agent is making his task. I mean, he's accomplishing his mission. But in order to achieve more and to reach more, let's say, user engagement with those bots, it's crucial to add some social skills, social and soft skills to our bot, which is very present in human conversation. I mean, we use a lot of emotions, we express emotions, and we try to understand the other participants' emotions during conversations. So when we talk with the bot, it's better that this technology includes some understanding of emotions and maybe also showing some empathy during the conversation. So that's why we are interested in detecting emotion in conversations. So I will start by a definition, let's say, of these fields. It's very important to distinguish sentiment analysis from emotion detection. Actually, emotion detection is a branch of sentiment analysis. So I think you all know that it is the NLP field whose core intent is to analyze human language by extracting opinions, ideas, and thoughts through the assignment of polarity, either positive, negative, or neutral. And it's usually used to classify, for example, product reviews from social media and so on. Emotion detection seeks to extract, let's say, finer grained emotions such as happy, sad, angry, for example, for human language. So rather than a general polarity. So the goal behind this, for example, for businesses, is to be able to provide optimal services to customer. I mean, there is a need to identify the different emotions expressed by people in their review and use this information as a basis to provide bespoke recommendation, for example. For example, in some e-commerce platforms, we can see a rating and ranking system that usually we can interpret easily, but also we can see a lot of reviews, like written reviews, and many emotions expressed in those reviews. So it's better, let's say, it's more accurate to have the label, the emotional label, rather than positive or negative. So we talk a lot about customer services when we talk about emotions, but also emotion detection is very, is used also in some other application, more critical, let's say. For example, emotion retrieval from emails and notes that, for example, express depression or people who are seeking help. Especially in the context of the lockdown and the coronavirus, we are using those technology to detect, for example, if people are, they need help, they need a human intervention when they call the call bot, for example, of Zaion. Unlike detecting emotion from the voice, which we do also in Zaion, we have a team, a voice team, let's say voice lab team, working on voice technologies and speech. Also, we can detect emotions from images and other multimedia methods. But in text, it's like more complex. There is a lot of challenges. I think this is due to the complexity of human languages. We use a lot of metaphors, which are language specific. Also, often emotions are also an informal aspect, so we tend to use informal vocabulary, which evolves very quickly. It's also very related to, um, it's also very related to the social class and also the location. I mean, the area and the geographic area. Also, you can see that one of the challenges in the text is that emotions in text, they are intracultural and cross-cultural, not, for example, in voice or especially in facial expressions, which are universal. When we express our emotions through the text, it's very language specific, so we have to master this language to understand which emotion we are displaying, let's say. Also, when we tackle this problem, um, we identified that there's not a lot of data sets that are labeled, and it's very hard to label such data because emotions are very subjective, and even people in Zaion lab when they are annotating, we cannot have many, let's say, agreement on the label. So sometimes there are situations that are critical. Also, we don't have a lot of public annotated data, but we will see it later. When it comes to conversation, it's even more complex because in conversation we have a lot of short texts. We can use emojis. We can have grammatical errors, or if it's a vocal conversation, we can use speech transcription, which may contain errors, and the error will be, will induce some errors in understanding emotions and also language. So we have a lot of challenges here, and I think the main one, and it is the last but not least, it's the extraction of contextual information in conversation. So we will see why context is very important. So, for example, if you want to automatically detect some emotions from these sentences that you are seeing in the screen, I started crying, or just try to do that once. I think it's impossible to be accurate because we don't know about the context. We don't know why this person is saying this. And also, I started crying for. It can be sadness. It also can be happiness. So when we see the entire exchange, let's say not the entire, but some more content, some more information. The first one, I just qualified for the NABER internship. That's great news. I start crying, so it's happiness. And now we can be accurate about the detection. And the second one, it's anger because people are arguing with each other. So with little more content and context, we can be accurate in emotion detection. So fortunately, we can find some data sets in literature and used in some research work. So I wanted to share with you some of those data sets available and their characteristics. Sorry. So the first one, I think it's the most common one, the International Survey on Emotion, Antecedents and Reactions. So it's a database constructed by the Swiss National Center of Competence in Research. So it consists of 7 emotion labels: joy, sadness, fear, anger, guilt, and disgust and shame. And it's cross-cultural, and you can find 7,600 sentence annotated. So it's only sentence. So the Emo Bank, it's also very known. It's very large, so we have 10,000 sentence, and this data set is particular because it's not a classification data set, because it is based on another emotion theory, which is the valence arousal dominance theory, and emotions are not discrete, they are not categories. It's a score, so it's very particular. So this database was obtained from new headlines, essay blogs, newspaper, letters, and travel guides. So it's very, very big. It's very wide. The WASA Emo Int is the workshop of computational approaches to subjectivity, sentiment, and social media analysis. So it was constructed to detect emotion intensities also. So it's not categories, it's not a classification problem. It's kind of regression problem. So we have a score, and it's based on tweets. Some of other data sets that are less known, for example, daily dialogue, which is dialogues built by crawling dialogues from regular human conversations. It contains 30,000 sentences annotated for neutral, anger, disgust, fear, happiness, sadness, and surprise, and others. Another one, which is Crowdflower. I don't know if you know. I think most of you know this tool. It's a very good tool. Which made available their data sets containing 39,000 of tweets, and annotated also for 13 emotions. So it's surprise, happiness, sadness, anger, but also boredom, enthusiasm, relief, empty, and neutral. And the last one, which is very interesting for us. So I decided to describe it in detail. So it was a competition conducted in 2019 in Sem Eval, which called Emo Contexts. So where about 300 teams participated in the task of emotion recognition. So this database is obtained from conversations between virtual agents and the user. And it's a dialogue database, so it's a 3-turn dialogue, and you can find it. I mean, you can search for it in the internet, and you can have this database for free if you enroll to the group in LinkedIn. So if we focus on this last one, the last database, which is very interesting. So the data structure is as follows. So you can see it on my screen. You can find 3 turns, and the last turn, the third one, is the most interesting for us. So the task was to try to detect emotions from the third turn, knowing the turn 1 and turn 2. So it was obtained. It contained 30,000 dialogues, and we had 2 test phases. The first one including 2,700 dialogues, and the second test phase was about 500 dialogues. And for classification, we had sad, happy, angry for emotions, and we had a fourth category, which was others. So if you don't want to use public data sets, and if you have enough data to annotate, I think the annotation approach of the IMO context is very interesting. So it was four steps. So the first one was to manually annotate 300 dialogues showing randomly, so selected randomly to human judges. And once we have this first pool of annotated dialogues, authors used embedding, so they create embedding for those dialogues, and then they can identify similar dialogues in the pool using threshold-based Cousin similarity. And then also they used some heuristics that are known in emotion detection, for example, searching for opposite emoticons, like for example, the emoticon of crying could be a happiness expression. Also, we can use sentiment analysis to identify which dialogues are interesting for us. The length of utterance also, we know that angry people tend to write more than happy people, and so on. So there is a lot of heuristics that you can find in the second, article, and the first one also, Gebta and al, and also Palengi and al. And the last step was to validate the whole corpus, let's say the whole database with humans. So this is a very interesting approach because it reduces the cost of human judgments, and it's accurate. I mean, we don't lose accuracy. Okay, so let's move to approaches and models. I will try to not to be very long. It's the common phases in emotion detection and also in all, I think, text classification task is the first step is to represent the language, and the second one is to classify the inputs. So a common approach when we talk about language representation, when we don't have enough data, is to use, for example, pre-trained vector representation or so on. So we will talk in details in the next slide. So here I wanted to share with you some very recent work about emotion detection in texts. So the first one that you can see in the table, Ahmed et al. Detected emotions using cross-lingual embedding. So they built an emotion dataset called Emodis-E by crawling the Hindi news website to obtain disaster documents. So the data contained about 2,000 training samples and was annotated at the sentence level. So there is a limited amount of data in Hindi, so they used a transfer learning environment of cross-lingual word embedding involving Hindi and English to provide a shared representation of English and Hindi. So the F1 score was about 0.5, and but for the limitation, they didn't take into consideration the classification of emotions with the context. The second one also was based on tweets, and we had, those authors, one of their limitation was low extraction of contexts. The three last ones, Raghib, Chatterjee, and Wang et al., are three teams that participate in the SEM Eval 2019 with the EMO context database. So the first one, they presented an attention-based model for detecting and classifying emotions in textual conversation. The second one, Chatterjee and all also participate in the same task, and they detected contextual emotions from textual dialogues and classified into one of four emotions, like happy, sad, angry. So they used also LSTM, and they had F1 score of 0.5. And the last one, we will discuss this more in details because it was very interesting work here. So this was the architecture of their model, of their proposed model. So they were the fifth, in the top fifth out of 300. So it was a great performance. And they used pre-trained vector representation, which is GLOF, that captured fine-grained regularities. They also used another embeddings from a language model, which is ELMO, which are deep contextualized word representation. So it captures the variation of the meaning of a word depending of its context, which is very interesting for us. They also used the deep emoji, which is a pre-trained model containing rich representation of emotional context. So it has been pre-trained on the task of predicting the emoji contained in the text using bidirectional LSTM. And they also used the hierarchical architecture. So it's used for encoding dialogue context, like you can see in the architecture, to encode the multi-turn dialogue generation task. So it was used also in a generation task. So this work was particularly interesting for us because it was ranked among the five top of this competition, let's say. In the Zaion context, we use a lot of context to try even to understand some of the utterance, and also to show empathy. Like when you're seeing in my screen, it's the same utterance, it's exactly the same user demand. I don't need a replacement car, but it can be in different contexts. So the answer provided by the bot should be a little bit different. So for example, if someone, if you are in insurance and we can offer a replacement car for our clients, like customers, and the customers say, no, I don't need a replacement car. The bot can say, okay, I remain at your disposal if you change your mind, for example. The second is exactly the same request, but in a very different context. So the customers say, my car is totally broken. Unfortunately, nothing can be done. And now the insurance bot can offer a replacement car, and the person say, no, I don't need a replacement car. So we are trying, so it's our target, so it's our goal for 2021 to have to generate automatically, sorry to hear that, because we understand that the context is kind of negative, so the car is broken. So sorry to hear that. And then I remain at your disposal for any questions and so on. And in the other hand, if my car is finally fixed and I don't need a replacement car, it's a totally different context. So it's the same request, but a totally different context. And the bot can say, good news, I remain at your disposal. Actually, when we first talked about context, at first it was about emotions, but then we figure out that context is very important. It's beyond that. And we want, and we are using the context even to understand the user entrance. So what you can see in my screens, it's the conversational assistance now with the NLP component, intent classification, entity recognition, and then we have rules, and then we have the response, and we want to reach another architecture of conversational bots, which is based on the understanding of the context and then trying to select an action according to the context. For example, trying to choose one response from another, or slot feeling, or so on. We are out of time. I will try to be quick. So in the last part, we will talk about the evaluation of those approaches, those technical approaches. So it's very good to use the basic automatic evaluation, precision, recall, and F1 score, like all traditional classification models. But in this case, when it comes to emotions, it's more, let's say, it's different. It's a little bit different. For example, some misclassification are not that important. For example, we can classify some nutrients in disgust, but actually it was fear. But sometimes disgust and fear are very similar, so it's very hard to interpret the F1 score or the precision score when it comes to those misclassification. Or also sometimes you have a low confidence score, but it doesn't mean anything, because sometimes we express our emotion in a very implicit way, so we are not able to be sure that this utterance is classified in this category. Also, like I said in the beginning, the label data also is very qualitative when we have human judgment, but the human judgment is also very subjective. Some people can find this as fear, and other people can find it as an expression of disgust, and so on. So we also recommend to complete this evaluation with a human evaluation and user evaluation by evaluating how the real conversation are going, and trying to analyze some the behavior of users when we add this kind of components. So as a conclusion, the takeaway message from this presentation is choose wisely your annotation approach, because it's very important. If you have enough data, or if you don't have enough data, you can use some public data set. And here also you have to choose wisely your data set. And the emotion theory, which is with it. Also, the context is very important for emotion detection, but also for understanding and response selection in conversation. And also try to include human evaluation and to complete your evaluation with the human part. And it had to be based on a real conversation. So thank you Thank you for your interest. I hope it was interesting.
Right. Thank you, Alya. I found it very interesting. I want to suggest that you respond to the questions in the Q&A in writing. Because we have a second speaker today, I want to give him the full amount of time that we promised to him. So I want to suggest that you do the written response to the questions. I'm sorry we don't have, there are quite a few of them, which is great. That's a mark of a great talk, that people were really responsive to the talk if it generates a lot of questions. Let's transition now to Christian. If you'll stop your share, we can have him start his video and unmute himself. Again, I'm not going to give long introductions or anything like that. So Christian Kasim Loan is with Snow Labs, which we thank for sponsoring the meetup, and he's going to talk about the Spark NLP. So you can go ahead. I can hear you fine if you want to start sharing your presentation.
Yeah, give me 1 second, setting up the screen. So hi, everybody. Nice to meet you all. I'm very happy for the time today to give me your attention and to let me show to you today the great NLU library. So you can see the PowerPoint right now, right?
Yes, you're good.
Okay, wonderful. Yeah, so let's get started. So today you will learn how you can capture the power of over 1,000 state-of-the-art models in over 200 languages for various NLP problems in Python in just one line of code. It's called the NLU library from John Snow Labs. We support over 200 languages. They don't even all have a flag and they don't even fit in here. And we will learn today a lot of things you can do with NLU because there are various amounts of things. First of all, I will give you in a second a quick recap of what is Spark NLP and what is John Snow Labs, in case you haven't heard of us. And then we will spend most of our time today coding. And we will see a lot of the easy one-liners, how you can do easy spell checking, sentiment analysis, part of speech, classification for various text problems, and get all of the state-of-the-art Bertology embeddings like Elmo, XLNet, Use, and many more. After that, we get our hands dirty with a little bit of data exploration. I have a Bitcoin data set prepared for us with the latest headlines of Bitcoin news articles. And we will see how easy it is to analyze and look into your data set and extract keys unsupervised, extract sentiment, part of speech, or even NER. After that, we will take a quick peek at the multilingual capabilities of NLU. I will show you how simple it is to translate with the new Microsoft, like the new models published by Microsoft called Marian, which are now integrated in NLU. And you can use them to translate between 300 languages. And finally, we will check out the latest model from Google, T5, which has been released last year and has shown lots of interesting applications in sequence-to-sequence problems in NLP, where the most interesting ones are definitely question answering and summarization. But there are overall 18 different tasks you can do with the T5 model. So first of all, what is Spark NLP? So Spark NLP is the foundation and builds the back end for NLU. Spark NLP focuses on providing the most scalable, the most accurate, and fastest model out there. And it has proven itself numerous times to be the leading NLP solution for the industry. And it is now the most accurate and also most used NLP solution in the enterprise. And we have been awarded numerous times for that. And so we have all these great and powerful models in Spark NLP. And if you don't know, Spark is a big data text processing library. And this is for big data guys. But not everybody is a big data person or wants to deal and handle with Spark. And this is why we have introduced NLU. It wants to be a truly Pythonic library that integrates into the Python ecosystem seamlessly with libraries like Python, Pandas, or sklearn. It is fully open source and completely free to use. And so, how does it work in a nutshell? All you need to know are basically what are strings in Python and how to call methods. You basically have the NLU module, and on it you call NLU.load. And then you put in a string. And this string represents the model that you want to load. For example, sentiment model or any R model. And this will give you a pipeline. You can even call this a model. And on this pipeline or model object, you call it .predict, and you give it the data. And then, depending on whatever model you specified, you get the predictions you wanted, returned as a pandas data frame. Or depending on the use case, even other data formats. And so more concretely, you just say NLU.load emotion, and then you say .predict, I love NLU, and this gives you a pretty pandas data frame. And here's the concrete example. If you run this in a notebook, you get a pandas data frame where you have the sentence embeddings generated from use, the universal sentence encoder. So these are attention-based embeddings. Then you also get the confidences for various emotions. So this is a 4-class emotion classifier. It classifies for surprise, sadness, joy, and fear. And we will take a look at it in a bit again. And so we see it properly classified this category as joy. Cool. And so NLU works with various data structures. You can give it strings. You can give it lists of strings, of course. But also you can give it a pandas data frame, like we've seen, or even a pandas series, so just a column. And if you want to scale with NLU, there's still a big data way with NLU. And you can take the big data path by using Dusk or Ray with Moodin-based data frames, basically, that allow you to scale to multiple clusters. And also, we still support Spark data frames because under the hood, we still have some Spark left. So, and another simple example, if you want to do language classification, you would just say NLU.load, when you say lang, then the name of the classifier, and then you put the data in there. And you see it classifies properly the English sentence. NLU is an open source library as English, and the French version of that as French. Cool. And there are numerous amounts of classifiers. We have over 50 different classifiers for various problems. Another interesting one is the fake news classifier. And you can just say en.classify.fake news and say unicorns have been sighted on Mars. And that will, of course, be classified as false. Cool. And NLU gives you, since with NLU, you can grasp so many features so easily, like all the embeddings, all the NER features. You can explore your data set very easily. This is an example you can see here from a test-me exploration with NLU. We will not cover it today, but I will show you the links to the NLU notebook that shows you how to do that. And it just takes like 3 or 4 lines, and you can cluster your data set in you first embed your data with high dimensional embeddings, contextual embeddings like Elmo, Bird, we have over 50 of them. And then you can map it back to 2D with test.me, and then you can search for semantic clusters. And you can see already here in this picture, these pictures are colored by part of speech class. And you can see these were generated by, so these are 6 different embeddings in this picture. And so, for example, the one in the middle is generated by Albert. And you can see certain classes are already clustering or have been clustered. And there, of course, you can see in the other comparison, you have Elmo, Love, XLNet, Electra, and Bird. And you can get all of them in one line and pretty easy with NLU. I will show you later how to. So you can also extract keywords in just one line and then plot the keyword distribution in the same line. All you say, oh, well, you don't see the beginning, but you would say NLU.load Yak, which is the Yak classifier algorithm, .predict on a data frame, and then you get the keyword predictions data frame. And on it, you just call explode, and then you have a distribution of keywords. And we will see this in action in just a few minutes when we get to the Bitcoin dataset, which is about now. So first, we will get to a warm-up notebook. I've already warmed it up for us, so it's all warm. But maybe I should show you first of all how you would install NLU. So first of all, you would Google maybe John Snow Labs NLU, and you can go to the very first page. We have very pretty documentation, and you can go to the docs, and there's very quick, very simple quick starter, the super quick starter, which you can see right here. You can copy all of that and show that in the Google Colab notebook. And I already did that, so you don't do that again. But then you would run that, and you have a Google Colab environment ready with Java and NLU and Spark NLP, so all ready to go. And so what we will see now is a few of the basic features you have with NLU. So the first example would be sentiment classification. And as we have already seen, all you type is just NLU.load sentiment.predict. I love NLU and rainy days. And we can see again also in real time that the analyzed sentiment model is being downloaded and it predicts properly this is a positive sentence. And this time is binary classification. We'll take a look at multi-class emotion classification in a bit. Of course, we have more basic feature generation, like part of speech. We have part of speech for over 30 or 40 languages. You can find them all on our website. I can show you in a bit. And you basically just type NLU.load part of speech. You just say the classifier and then .predict part of speech assigns each token in a sentence a grammatical label. And so what you will get is a pandas data frame, where one column is the token, it's the tokenized text, and the other one is the part of speech class classified. And so we have different, we have only one part of speech classifier for English. Or we have actually multiple ones. You can see it all in the docs. But what I want to say is, we in the docs we have the simple examples, and then you have the part of speech section, and then you have all the classes which are predicted by the class of speech part of speech classifier. And so you can check up if you don't know them all at the top of your head, and you wonder what is the JJ. So because it's the word grammatical in the sentence is the JJ. You can just look up here. Oh yeah, JJ is an adjective. Yeah, makes sense, right? And so you have all of the powerful one-liners in this simple example section in the doc. And we will get to it back in a bit. But next, what I want to show you is named entity recognition. Named entity recognition, you might know already, assigns tokens or chunks, which are basically concatenated tokens, so groups of tokens, classes of names. So basically, you can identify in a sentence named persons or locations or companies. So for example, you could input the sentence, John Snow Labs congratulates the American John Biden to winning the American election, and it will classify properly the classes John Snow Labs, which is a person, and the American, which is also a person, John Biden is also a person, and American is a no RP. And so you might wonder what is a no RP. And so in this context, or our classifier, which has been trained, so we have multiple NER classifiers, and this one is trained on the onto nodes, which, by the way, you achieve state-of-the-art accuracy with our NER classifiers. And what we wanted to know is what's the class of American. So no RP is basically, like I said, I wanted to say is basically like a nationality, like the Germans or Americans, right? Cool. So next, you could use NLU. So there are so many models. It's hard to keep track of them or see what's going on with thousands of all of these models. So we have some inbuilt functionality in NLU. You can just say NLU for print components, and then you say the action you want to know, like search for. And then you see all the models that could be downloaded or put in the NLU load method. So there's one for Dutch, NL, right? or French, or Norwegian, or Polish, Russian, Finnish, and there are various of them. There are bigger models which use big embeddings, or heavy embeddings, and also smaller models which use smaller embeddings, and are of course faster, but of course are also less accurate. And so depending on your use case, you can use the right model. And so to give you a little more of the docs overview, so by the way, so if you want to know more about the models, what I can recommend to you, we have this, what is it? The pipelines and models namespace. There you have a kind of cluttered table of all the models that are available, and we have a better website available, which is the John Snow Labs Model Hub. But here you have just a rough table of all the models, which is a lot. And every NLU reference, by the way, so these are the parameters you put in the NLU load method. And it will map to a Spark NLP model that will be downloaded. And you can see already there are a lot of references for various models. These are just the aliases, right? These are just the base models. And you see there's COVID bird, Elmo, and various classifiers for questions and spam. And if you go further, then you see just the models by language. And you can see there are so many languages and so many models. So it's really cluttered. So I can keep scrolling, or you can go back to the top. And there's the amazing models hub, which will link you to this page. And this page basically indexes all of John Snow Labs models, and you can filter here by whatever task or language you want to work on. So you want to do sentiment analysis, so you put in sentiment analysis and you hit go. And it will give you all the models for sentiment analysis which we offer. And you see there are English sentiment analyzers, but also for Thai, for example, or Urdu, and also some other languages. And so you could click here and say, okay, I want this Thai sentiment analysis model. So you can read here a little bit about it, how it has been trained, read some examples about it, and soon there will be here a reference for how you can load it in NLU. But right now it's not. So what you will do is you steal the Spark NLP reference from here. There's a dot pre-trained, and this is the Spark NLP reference. You hit Control C and then go to this page and Control F, and I guarantee you will find exactly that model on the right side. And if you now put in this in the NLU load, you will get that model ready to go for predicting Thai sentiment. Cool. Now that you know a little bit about how you can find your way around all of the NLU models, let's get back to the basics. So the last thing about the very easy one-liners is just I want to show you is how to get the classic bird and Elmo embeddings, and it's as easy as it could be. You just say NLU.load, and then you put in whatever embedding you want. So you can say bird, and then you predict. You put in a string, or you can put in a data frame, and what you will get returned is a new pandas data frame with the embeddings. In this case, bird, but you can also swap for Elmo. You can also put XLNet or Albert. We have them all. And these are, by the way, token or word embeddings, how you might call them. But we also offer sentence embeddings. So while we will embed a whole sentence for you and generate from this the embeddings. And so you can either use that to classify whole sentences or documents, or if you want to build a document classifier, you can use it that way. And so there's a lot of embeddings out there. You can again use the NLU.print components, and you can say the action is embed, and it will show you all of the embeddings, and there are quite a lot of them. You can actually scroll a bit, and so there's a lot to find in there. We have Chinese, Arabic, Hebrew embeddings, and many more. Cool. Now that we are done with the total basics of NLU, the easiest stuff, we will get to the extracting data from a Bitcoin dataset after I had a drink of water. So now what I have for here, for us here, It's a Bitcoin data set. I got it from Kaggle. It has a lot of titles from various Bitcoin headlines. So you can see here, so it was posted on Kaggle, and it just is the headline of news articles over a span of a few years. And so some are positive, some are negative. And what we will do is we will predict the sentiment, or first of all, the emotion. And so what we will do is just we say NLU.load emotion, and then we say predict DF, and what NLU will return for us is a prediction for every row in the data set. And so we have the sentiment DF, or in this case, it's the emotion DF, and we have the emotion prediction. And we see here, for example, Bitcoin price update will lead us down. So it's a fearful news, or national bank citing highly flawed is also fearful. Or Bitcoin open position sounds positive, and so if you go around the data set, you find various examples for it. And you of course also have the emotion confidence. And so what you can do with this now is you can plot the distribution of the classes very easily. So you have of course the sentiment, DF, and you just say sentiment.emotion or sentiment dot value counts, which will give you a series of all the different counts of classes, and then you can easily plot it as a bar plot, and then you have the distribution. And so we see most of the news are joyful, some are fearful, some are surprised, and a little bit sadness. Interesting. So we already got some insights of this data set and of the news headlines. And so we could also, if we had some more time, group this by time and see and analyze how the sentiment classes basically behave over time. Cool. And so next, we will get to a very cool algorithm, one of my favorite algorithms, because it requires no training and it's pretty fast. It's the Yak algorithm. If you haven't heard of it, this stands for yet another keyword algorithm, or extractor actually. And it extracts keywords unsupervised. So we don't need to train it. We just say NLU.load Yak, and then we predict on the data frame. And what do we get? We get a column with keyword classes. And there we see what potential keywords are in the text. So for example, for this first string, it predicted successfully. It's about updates or China, and also about China leaving something. And then for the next row, it's talking about price levels. And so you can configure this, or first of all, you can easily plot the distribution of your keywords with just one more line. So you could squeeze this into one line, but you can also not do this, so I keep it a bit more readable. And so you basically call, because this is, right, your keywords column is a list of strings. So if you explode it, you have one row per element of this list. And then you can again do dot value counts and a dot plot bar, and then you get a pretty distribution of all your keywords. And so we can see it already makes a lot of sense. This data set is talking a lot about Bitcoin and about Bitcoins. This is not good. We will get to this in a second. Or price, except Bitcoins. I hope you can read this. Maybe I can zoom a bit. Oh, but it's scaling and not with the scaling with the zoom, so whatever. But yeah, currency and various other things. So we can have a lot of fun with this, but we can also clean our data, because what is not nice is that Bitcoin and Bitcoins is the same, and we don't actually want that, right? Or depending, maybe for your use case, you might want that. And so it's always use the right tool at the right time. And so right now, the right tool is to use stemming, to stem your words. And if you don't remember what stemming is basically cutting off the end syllables from your word. And so this will make Bitcoin, Bitcoins become Bitcoin. And we will see the count of Bitcoins will increase a lot. And how do we stem a data set? First of all, with NLU, it's super easy. You just say NLU.load, and then what you put in there exactly, you guessed it, stem. And then you say dot predict, and you say whatever data set you want to predict on. And then you might have to configure the output level, which we can specify later again. But output level, in this case, document just tells NLU that give me one row per input row. So we will get a new data frame, which has the stemming column, and the stemming column has the stem token for every token in the data set, right? And so from this array of tokens, we need to build a joint string again. So in the next line, we just call stem. So we just join the string on a white space in this column, basically. And so what we get from that is the stem string column, and that represents the whole sentence, but with stem tokens. And so now we can feed back the stem data into the Yak algorithm. And now we see that Bitcoin and Bitcoin is disappeared, and it merged actually. And now we have 700 appearances of Bitcoin. How many was it before? Before we just had 300 and around 50. And this year the Bitcoin is just 50. So 350 plus 50 is 400. So we actually covered 300 other Bitcoin occurrences besides the Bitcoin Z. So it's pretty useful and handy in this situation to stem. And depending on the use case, you might also want to norm or lemmatize. And how do you lemmatize or norm? You basically just write norm here and then do the same all over. How would you lemmatize? You just write lemma. Bam, that's it. And that's how easy it is basically. You just need to know these references, and these are not hard. You don't need to remember them. You just go to the model hub, and then you have it all here. So it's very easy. And so let's take a closer look at the Bitcoin data set, because let's have a better look at the distribution. So what we have here actually is the top 100 keys, and now we just look at the top 2 to 99. So I just made Bitcoin disappear so we can have a better view of the distribution. And we see is still talking about price, except Bitcoin, a little bit Dogecoin, a little bit FAT, Coinbase, China, sale, and so what else here, paid. So maybe, right, if you want to be a trader, you could use this and definitely gain a lot of insight about what's the market thinking, what are people thinking, and what's going on. Of course, if you're not a trader, you're just social media person, you can of course understand what is your social media, like your social domain thinking, and extract a lot of data from just Twitter or any text or Reddit or any text data set out there or data source. And so this was just a simple Yak, but you can configure Yak actually to work a little bit differently. And there are a few parameters. The most important ones for you to know, which we will cover now, is set and keywords. If you can change the parameter to basically increase the parameter, so the Yak algorithm will return more keywords. By default, you might have noticed we always get, when we go back up here, 3 keywords per sentence. But we can force Yak to give us more. And also, if you are curious, go read the paper. It's a very good paper from very smart people. But basically, under the hood, it's using co-occurrences and n-grams. And you can tweak the algorithm to use different amounts of n-grams and different values for the confidences. And this will, of course, give you different results. And so, first of all, how do you tweak a model? How do you set a parameter on NLU? It's again super simple. We try to keep it as simple as possible. And what you do is just you load the object, the pipe object, and on it you call print info. And what you will see is it prints out for you every parameter you can set on this object, on this model, or pipe actually, because under the hood, there's happening a lot of magic. You don't only have one model. Under the hood, there's a whole stack, a pipeline of models. Under the hood, you have a document detector, a sentence detector. You have sometimes a normalizer or tokenizer. So NLU is hiding a lot for you. And if you want, with the NLU.print info, you can see all the magic and you can tweak it as you like it. And so in this case, let's say you want to tweak the N keywords, you just copy paste this, literally copy paste, and you have the explanation here also. You would copy paste this, bam, and then you just swap the variable name, and then you're done. And you put, of course, something in there. And so I did this already for you in the next cell. And basically, you can change, for example, the set n keywords to 4, and then predict after you set that. You predict with that type object, and now you have 4 keywords from your from each row in your data set, basically. And of course, again, our distribution of keywords changes. And then it's again interesting to look at how does it behave, what do we learn, what are the differences. And the same is possible with changing the min n-grams. And this again gives you different results for your distribution. And it's very fun, definitely. If you want to look at something, look at Yak and then the other stuff. Yak, you don't even need to download Yak because there's no weights to download. It's already all in there. But all the models are also being downloaded automatically. Cool. So now we covered the data exploration part, just to show you some more of the cool things we could have done, what we don't totally get to. Basically, all of the classifiers, they are also covered on this simple example page, by the way. And you see here, there's the emotion classifier, 4 classes, sentiment, question classifier, spam, cyberbullying. And for all of these classifiers, it takes literally 1 line to get the distribution of features, like we did here, right? Because you literally just call NLU.load, put in like spam or sentiment, any of the classifiers, and then you can say like result.valueCounts.plot.bar, and then you have whatever you like as a distribution. So that's super handy. And there are various like different sentiment classifiers trained, and so on. Cool. Now let's get to the multilingual part. So with the latest release of Microsoft's Marian model, there are over 300 models translatable in NLU. This is actually a typo, sorry. There are around 300 language pairs translatable in NLU, and it's a very simple syntax you need to know. First of all you need to know is we use the ISO standard codes for languages. So you just need to know what's the name, like the ISO shortcut. And then you need to know the schema, like what you put in the NLU.load, in the NLU load method. And all you say is NLU.load, and then the start language, for example, EN, and then .translate, and then you say the target language, and then it could be Turkish or English. So you say EN.translate to French, EN.translate to, and this should be, for example, Hebrew. But exactly. So let's look at it in a more concrete example. Here I have the same data set with Bitcoin articles, and I'm translating it for us into German. And all we do is saying en.translate to DE. And so I can now vouch this myself. Bitcoin price update wird China uns nach unten bringen. So we don't see the whole thing, or die Nationalbank Australia Bank is hochflawed. Also is flawed. So it makes sense. For me as a German, this makes sense. If there are any languages you want to see showcased or demoed, definitely put it in the questions or comments. We can definitely demo some of your favorite languages maybe later. But for right now, I have 3 models prepared for us. The German one, and you see here all the German translations. If you want to do French, easy as pie, you just say en.translate to F French, and then you have the French translation, or even Hebrew. It's super simple, right? You just need to know what's the shortcut for Hebrew, en.translate to Hebrew, and then you put in the data frame in your pipeline object, and what you get out is actual Hebrew translations of your Bitcoin news articles, right? This gives you a lot of powers to analyze data sets and multilingual communities. So that is very powerful and very interesting. And you can find all of these models. It's a bit hard to fit them all in a notebook and prepare them because they do take up a little bit of size. But you can find all of them, of course, where the best place to find them is in the Models Hub, right? You can go to the pipelines in model space, and there should be translation. And then you just go click go, and you will see we have 14 pages of translators. So you can definitely, anything you need, we should have it. Almost anything, but soon probably anything. Cool. So now we covered the translation part. So now we get to the T5 part. So you might have heard of the pretty cool T5 model that has been released last year from Google. It has been pre-trained on the whole world, almost whole World Wide Web. It's like the C4 data set that consists of terabytes of data. And so the T5 model has all the knowledge of all of Wikipedia basically stored in its weights. And it has been trained on various tasks. And when I say various, I mean a big amount of tasks, around 18 tasks or 19, depends how you count them, how you count them. And these are all of the tasks right here, which you see. And these tasks stem from the squad and superglue data sets and tasks set. And so you might want to check them out all in detail later. We will take a glimpse. But the most interesting tasks and problems you can do with T5 is definitely question answering. And there are basically two types of questions you need to be aware of, which basically also will cover, I think, all questions, almost all of them. So the first one is an open book question. An open book question is basically how most school or uni exams are basically. You go to the test, you don't have any helping, you're not allowed to use a mobile phone, you just go there, write the test with only the data stored in your brain and your weights, right? And then that's it. And that's exactly how T5 does it. On open book question, you just give the question and it gives you back an answer. You basically give it no context. But in a closed book question, oh, sorry, crap, I mixed it up, sorry. So that was a closed book question, right? In a closed book question, you're not allowed to bring information from the outside. In a closed book question, you are only allowed to use what you have stored in your brain in the weights. But in an open book question, you are allowed to use additional context. You would be allowed to use your Google or use your phone in a test, for example. And so this means for in T5 terms that you give it a question and some context for the question. And this is basically why it's called open book. The context is some help which T5 will use to answer the question. Usually you ask a question about the context. So a simple example would be if you have the text, Genghis Khan called Subtai back to Mongolia. And soon afterwards, Jebe died on the road back to Samarkand. And then if you ask, where did Jebe die? Now this is the context, right? The stuff, the little story was the context. And the question is where did Jebe die, and the output is Samarkand. So NLU actually understood the question and the context, I mean T5, and gave the right answer. And for a closed book question, that is basically T5 has to use its general knowledge, everything that's stored in its weights. But it knows a lot, right? It crawled all of Wikipedia, so it can answer a lot of general knowledge questions. So you can ask it, who's the president of Nigeria? And it will tell you Muhammad Buhari. And if you Google it, that's really the right president of Nigeria, if you don't know. And also, if you ask what's the most spoken language in India, it will tell you properly Hindi. Or what's the capital of Germany, it will tell you Berlin. And so, how do you do it in NLU? It's super easy. You just say nlu.load en.t5, and this will give you the T5 object. And then you can ask it questions. You just say, hey, T5 dot predict what's the capital. So you just put in the question, and it tells you, it gives you the answer as a pandas data frame, and it tells you Berlin is the capital. Same for Nigeria, right? Ask what is the president, or what's the most spoken language in Hindi. Cool. Now the more interesting questions come in, the open book questions. So we already saw this Jebe example, But a more cool example, so I copy pasted this news article or a part of this news article from BBC News, and you might have read it a few weeks ago. It was about Jack Ma, the founder of Alibaba. He reappeared somewhere. And basically he popped up in a Zoom meeting or something. And we can give basically the T5 model, the whole article. I just gave it now a snippet, but the more you give it, the better, of course. And now we can ask it questions about this article. For example, we can ask, who's Jack Ma? And so we just formatted this all to this nice format, but the output will be, who's Jack Ma? He's the Alibaba group founder. You can also ask, who is the founder of the Alibaba group? Well, that is Jack Ma. Or when did Jack Ma reappear? On Wednesday. And if you check, it really says, blah, 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 teachers meeting on Wednesday. So that's correct. And how did the stocks, it even understands the stocks. That's pretty cool. How did the stocks react when they surged by 5%? Cool. And so on. So, and who did Alibaba meet? 100 rural teachers. And so on. And the final cool question is, yeah, who did Alibaba hide from? Well, Chinese regulators. So that's pretty interesting. And finally, yeah, of course, you can also, so this is a pretty long string about a medical text. It's like the medical record of a patient writing down what happened to him. And you could all read this if you're really interested in a medical record right now. But you can also just, for example, ask a question about it and see, you basically ask, what does the increased concentration in the lungs like displace? And you see it's carbon monoxide. Cool. And now the last cool, like one of the most interesting tasks in T5 is summarization. For example, here are two sentences which you can easily summarize. So we don't see it so easily in the data frame. That's why I prepared another sentence actually here. I went to hackernews.com this morning and I read a cool news headline, this one, MasterCard adopt cryptocurrency. And I literally just copy pasted all of this and threw it in here. This is the whole article. And this is, how long is it? It is 1,284 characters long. But you can now call the summarizer model. You can say T5 summarizer dot predict, and then you give it the text. And now you have a summarized version of the text that's still pretty long, but if you count the characters, you will see it's just 352 characters long. And if you read it, it still has most of the semantic meaning in there that MasterCard adopted or will adopt cryptocurrency. So that's very interesting and very useful. You can reduce the dimensionality a lot and also save a lot of time. And so now to just take a quick peek at all the other things you could do. Not all of them are useful for everybody. They are very niche like applications, and mostly these tasks serve to train, to give like the T5 model all the background knowledge it needed and to like tune its weights. But one of the like you could, for example, you can classify grammatical correctness between two sentences, or classify, that's what's also very interesting, if one statement is deducted from another one. So you have a lot of logical statement, logical deduction abilities. And also if you classifiers and the question answering. And so you can even, that's pretty cool actually, you can even ask it multiple choice questions. So if we go through it, so this is a lot of examples. I cannot cover all of them, but this is the multiple choice one. It's pretty cool. You just say, you give it a question. So why was Joy surprised for breakfast? And then you give it also a candidate for an answer. So maybe the answer was a T-Rex was in the garden. And if you read it all, there wasn't a T-Rex. He had only pie for breakfast. And the cool thing is now, the T5 model tells you this is the wrong answer. And so what you could now do is you could loop over all your answer candidates. And then basically for one answer, T5 should tell you, oh, this is the right answer. And then you have the answer to your multiple choice question. And so maybe you can try play some fizz games with that. Definitely has a lot of capability. Cool. So all of this what we covered today.
Let me suggest. Can we wrap up? And you have a lot of questions. It would be great.
Yeah. I'm literally about to wrap up. Literally, was about to. Yeah. So all we did today is on the NLU GitHub page. If you head to the NLU GitHub page, you have this examples folder. By the way, you also have this pretty GIF of all the features, but you have this examples folder, and there's the NYC DC meetup. Everything we did today is in there. But also, what I definitely recommend to you, go to the collab folder, component examples, and there you have literally everything you could do with NLU documented. I recommend all the classifiers and the word embeddings. So there's amazing and a lot of things you could do with NLU. So okay, yeah, let's wrap up. Demo time is over. I hope you enjoyed that. Let's just catch up with slides. Basically, yeah, so wrap up. What does the current NLU 1.1 include? 100% open source, over 1,000 models, over 100 of the latest NLP attention-based embeddings like BERT, Elmo, GLOV, XLNet, BioBERT, Electra, pre-trained for various problems, sentence embeddings, multilingual embeddings, over 50 classifiers, over 200 languages, labeled and unlabeled dependency parsing, spell checking, one line of code, everything. You can use, right, the gate, keyword extraction, pre-processing, summarize, answer questions, 20 squad and group questions. You can train classifiers also and achieve state of the art. And also in just one line, we didn't do that today, but it's all covered in the docs and the examples. Achieve state of the art and even aspect NER or sentiment-based aspect NER. So this is all over 200 languages. Here again, a quick overview of the languages I generated quickly. And yeah, we do every 2 weeks a new release, and that especially Spark NLP does every 2 weeks, and you as well. And that means every week we try to crunch out the best models and put in the latest developments in research to stay at the state of the art. So you can check always on GitHub. There's lots of release notes. So thank you very much for your attention and time. I hope you enjoyed this webinar, and please take a look at all the social media articles we have on Medium. And if you have any questions, feel free to contact me on any platforms.
Well, we do have questions. Thank you, Christian.
Yeah, I know, exactly. Let me see how to pull up the questions.
I see 9 questions left in the Q&A. We don't want to take too much time, but if you want to go through them quickly, that would be cool. And we
definitely. Oops.
We also have some questions in the chat, which we can try to get to. While you're looking at that, I will remind people that we will be posting the videos. I'll send the link again for the video. That should be up within a few hours. And I'll also mention that if you'd like to give a talk at a future program, you should send me a note. I'll put my email address in the chat in just a second as well. Christian, are you able to see some questions?
Yeah, definitely. Yeah, cool. Let me get started with the questions. So, currently, the first question, can you retrain models or fine-tune models with NLU or Spark NLP? That's currently not supported, but we are working on that and potentially in the future. Do you know about GPT-3 and if it is comparable to Spark? So yeah, I know about the GPT-3 model from OpenAI and Tesla, or Elon Musk, you could say. And we are looking into integrating it and different like smaller version of it because it's so huge, right? How would you fit it anywhere? But we're definitely looking into maybe get some smaller version of it. What's the biggest string count and you can work with? So that totally depends on the biggest string you can work with, depends on your machine. The more RAM you have, the more you can work with. So it's depends on the data set, on your RAM of your machine. And since everything can be scaled to a multi-node cluster, you could theoretically scale infinitely. So that's covered. How general purpose is Spark NLP's concept of language? Is it possible to define a sign language? So that's an interesting question. Sign language. Well, hypothetically, yes, you can train custom part of speech and tokenizers and custom models for everything. But maybe ping me again about that. That's actually an interesting question. I never thought about writing sign language. But theoretically, yes, as long as you write down the sign language in some kind of tokenized or tokenizable text, then of course, right? It's just a concatenation of symbols. You can classify that, right? Or predict with that. Which embedding would you use for document classification or clustering? Again, the right tool for the right task is often trial and error. Sometimes you want to try out different embeddings. That's actually what we do, or I would recommend. Definitely the bird embeddings are always very cool, but the gloves are also very nice. And you would try out multiple different ones, but you will always know the bigger embeddings are better than the smaller ones. But the big ones can be 2, 3, 4 gigabytes big. So that not every laptop can handle that, but we also have 200 megabytes big ones. So it's a spectrum of embeddings, and you want to find just the right place for you. Fine tuning, no, not yet. There is not a labeled data set. It depends what your label like interests in, but there's a lot of labeled data sets on Kaggle, and Twitter is basically an ocean of labeled data sets and basically a playground. And with NLU, you can dig around in the on the beach and build little NLP sandcastles. Cool. Cool, yeah. Aspect-based sentiment of news articles. So we have some aspect-based models right now available. We just started pushing them out, but if you search here, you can filter by aspect. No, actually no. But okay, we can go to the NLU page, and basically we have one aspect-based restaurant. So it was trained on restaurant reviews, and it gives you the directed sentiment towards an aspect. So if you say, I love the restaurant spaghetti, but the soup was awful, it will detect that spaghetti was good, you get the label good for that, but soup was awful, and you get the label soup bad for that. And there's even an example on the GitHub, a notebook you can look at. It's somewhere in the examples folder, of course. Examples, collab, and it's in NER, I think. Yeah, aspect, exactly that is. Cool. Exactly. So definitely I recommend take a look at that. Everything there's a link open in Google Colab in every notebook. If this would look, and definitely you could take a look at that. But sometimes it doesn't like to load. Oh, nice, we got it. Yeah, so you can click on this, open a new tab, and then you have it, you are ready to run them. You can say authorize GitHub, okay. And then it should open the stuff, or you can just download it. And then you get the entities. For example, there's a sentence, and you see the Thai main menu was positive, flavors was positive, but service negative. And if you read the sentence really quick, but the service was below average, and the chips were awful. And so chips was awful, service awful. So yeah, that kind of works pretty well. Is the easy way to reduce the size of the model or the run cost? Well, you can always use smaller models. We have embeddings like 200, 100 MB, small, but also 2 or 4 gigabytes. So we already try to provide to you the most small and useful model out there. So if you go to the embeddings page, that's actually pretty good to know. You have the pipelines and namespace, and you can control F and you embed. And let's go to this is the aliases, but let's go to the main models. It's a lot. And so now you see there's like there's cased and uncased version, right? If you have uppercase or lowercase text, or if it's all lowercase, there are different versions for that. But they are also based on dimension where the sentence. So most people like to use sentence embedding. So let me get embed sentence. And so we have a lot of different sizes for them. You just get the right side. So you have like the 128 dimensions, but there's also 248. We just get the right side page. But I definitely somewhere here hidden. Do search there, and oh yeah, there's the word exactly. You have the L is the layer, so you have a 2-layer with 78 dimension. You also have a 4-layer model, like 4 neural network layers, 478, but also 6 layers, 8 layers, 12 layers, so more layers, more accuracy, but also more size. But yeah, so if you go with the smallest, you have the most speed. And so we have, yeah, all of them, almost all combinations we have in them. Cool. Can you recommend me what to use for a simple sentiment analysis for children interviews? Oh yeah, it's super easy, right? We learned this today. Is you just use the default. Actually, I would just recommend the default, like en. You just do nu.load sentiment and then put in your text and do that. So there are a few different. There's like sentiment for Twitter, or also sentiment for movies, movie reviews, and also general sentiment. And so, and also like for use. And so is if you have labels and you can evaluate your model, I would test, is the Twitter one better or the IMDb one better, or also the other ones. So it's a bit try and error, test them out. But definitely it would be just one line. If you have pandas data frame with children interviews, you can easily get all the sentiment in one line very quickly, and then get the distribution point. Cool. How can the labor-intensive manual label be extended to provide more training data of the area of interest? How can the labor be extended to provide training data? So do you mean like, I don't fully get this question. How can the labor-intensive manual label be extended data of the area? So yeah, if you label more data, I don't totally get the question, Carl R. Maybe rewrite it, please. So that's answered. Can NLP be used to retrain? So yeah, you could use the sentiment aspect model, of course, also for news articles. So that definitely would work also on news articles. But of course, a model is always best in what it is trained on. But of course, it generalizes to other problems and topics and domains. And then it would work also for news articles, also, for example, or Twitter. Okay. Yeah, so I think we answered most of the questions. Maybe there's some more coming, or there's one more. Pre-trained embeddings deterministic? Good question. Yes, they are. So most models, right? They should be deterministic. I actually encountered one time a model was freaking XLNet. They put a random number generator in the embeddings for some reason, but that's not how it was supposed to work. I don't know. They had a, so embeddings should always be deterministic. You put in the same word, you get the same embedding. You put in the same sentence, you get the same sentence embedding. But of course, if the order of words change, you get a different embedding because the context changes, right? And it's context-aware embedding. So yeah, usually embeddings should be deterministic, or we have a problem.
All right, well, I think that's probably it. I scanned through the chat and I didn't see any unanswered questions, although there were a lot of comments in there. This is an excellent talk. Thank you very much, Christian.
Thank you very much.
I have some requests for you to share your Colab notebook. If you send me the actual
link, definitely.
You can put it in the chat now, but if you also send me the link, then I will post it along with the video in the video description and then the comment on the meetups to give people access to the slide decks and notebooks and all of that kind of stuff.
Definitely.
You know, we're just going to take a try here. I see James Solomon raised your hand. I'm going to allow you to talk. If you had a question, you can go ahead and ask it, James.
Thank you, Seth. Can you hear me?
Yes.
Yeah, we can hear you.
I had a question about the ambivalent spectrum you mentioned for basic sentiment analysis where you're only doing positive and negative. You normally would put that positive versus negative on one spectrum, either 0 to 1 or -1 to +1. And that's like a mean. And then the ambivalence is like the sigma of a probability distribution. Now, is that method preferable to having separate spectrums separate dimensions for positive and negative, because then if you have if you keep positive and negative separate as coordinates instead of sigma and mean, then you can add more emotions to that set of spectrum, and you're not stuck trying to combine probability distributions. I think it might be easier that way. And do you know of any data sets that have ambivalent emotions labeled for sentiment?
So, so definitely what you raised about there should be multiple classes, or it should be almost like an emotional gradient, right? From one like spectrum again. And there are multiple, so we have multiple emotion classifiers or sentiment classifiers, exactly for this case, right? Again, right tool for the right problem. We have two class, sentiment, but also we call it the emotion classifier, but it has like 4 classes. And now with the latest T5, I think they thought exactly about this problem. And this is why they have in T5, you can use the T5 for sentiment as well. You have binary sentiment, but also they call it regressive sentiment, which is on a scale between 0 and 5. Let me check. Oh, between 1 and 5. But it's not real regressive. It's actually 21 classes between 1 and 5. So they discretized the continuous range and made 21 bins. And so that would kind of reflect exactly what you are looking for, I think. It's the STSB task.
Thank you. I will take a look at that. Thank you so much.
Definitely. You're welcome. Good question.
Okay, great. Well, so once again, thank you, Christian.